Welcome to the RESP Fit training resource video on controlled negative pressure or CNP technology. My name is Luke Allen, president of OHD, and I want to welcome you today to our resource guide. Hopefully we'll go through some information that will give you a full understanding of our technology, resources, also regulations and guidances, all the way into how to conduct a fit test with our system. So my name is Luke Allen, president of OHD. OHD is a company that was founded in the early 90s. We started in occupational health, and we now are a global leader in respiratory fit testing technology, which really centers around the QuantiFit, which is the latest iteration of our system using CNP technology. So let's talk a little bit about CNP technology. What we do for fit testing is, of course, provide you a fit factor, but the way that we do that is that we pull a negative pressure on the respirator, and we actually look for leakage into the respirator during a fit test protocol. So different steps. And the higher the leak rate, the lower the fit factor. Obviously, the lower the leak rate, the higher the fit factor. So very straightforward. But a key thing is that each step, the employee or the firefighter or law enforcement personnel person will take a breath and hold it. Controlled negative pressure will pull a high work rate that you would see in the workplace. So it's very important to understand that. Our technology doesn't rely on the person to pull the breathing rate on the mask and the respirator. It actually pulls the breathing rate on the respirator as you would see in the steel industry or mining or any of these different areas, and it challenges that respirator for every step, every person, every time. So later on in our training resource, you'll see us go through a fit test, but it's important to understand that we're pulling that pressure and we're measuring leak into the respirator and then giving a fit factor. Our fit factors will be given in cc's per minute of leak rate. That can be converted into liters per minute, whatever you want to look at. But at the end of the day, the key is to understand the fit factor is derived based on a guidance that you're using. So ISO or OSHA or so on and so forth. So let's step into some guidances now and standards that you might be using in your RESP Fit training. So the first one is an OSHA 1910-134 Appendix A is where you can find all the guidance on respirator fit testing. Obviously, OSHA guidance is normally used in the U.S. market, but it is applicable for this training that we're doing today. The second is ISO 16975-3. That guidance is very close to OSHA. There's a few differences there, and I'll try my best to kind of cover some of these as we get through. But the main thing that you need to understand is the fit test protocol, the read-on protocol, are the same in both the OSHA standard and the ISO standard. One major difference with our technology in those two standards are the OSHA standard requires a 500 fit factor for full face respirators, and in the ISO standard it also requires a 500 fit factor for full face respirators. There is a different fit factor for other technologies, and you can look into your standards there, but it's important to remember that on full face respirators with controlled negative pressure, it's a 500 fit factor in both standards, and with a half mask respirator, it's 100, and that's pretty much commonplace across all regulations actually and guidances. But always check out the guidance you're using and really understand it fully. So let's talk a little bit about the read-on protocol that I mentioned earlier. You'll find this protocol in those two standards that I just referenced. The read-on protocol is key because it's very different than other technologies. It actually challenges the user to re-don the respirator multiple times during a fit test. This is extremely unique to our technology because other technologies, whether it's a qualitative or an ambient aerosol, you can't take the respirator off during fit testing. So I want to quickly highlight those protocol steps for you now before we get further into setup and things like that. So those steps are a face forward step where the person will don the respirator, they'll take a breath and hold it, the machine will pull that heavy work rate and look for air leakage into the mask. Step 2 is that person is going to bend at the waist, really parallel to the floor. You're looking for gravity pull on the respirator there. Step 3 is a vigorous shaking of their head. So that's key too. It is not a slight, slow movement as you'll see in other protocols. We really want to shake the head vigorously up and down, and they need to really talk out loud, very loudly talk. And what we're looking at is, does the respirator reseat on your face well when we do this step at the end? And then the last two steps to round out the 5 steps, step 4 and 5, are the read-ons. So you'll actually take the mask off, you'll get the straps adjusted, you'll re-don the respirator, reattach the mask, seal it to your face properly, and we'll do a measurement there. So that's a real quick overview of read-on protocol. We'll get a little more into that in just a minute. But let's step into some components of fit testing and also a little bit of requirements before you start a fit test. I don't have time today to go through every requirement that you'll see in the OSHA standard, ISO standard, or others that you need to do before fit testing. But it's very important that I pause here to say that you need to cover all of the test criteria before you start a fit test. Some of those things might be sizing, some of those things are comfort assessments, some of those things are user seal checks. We're not going to cover all of that today. We're really going to focus on our technology for this training, but be aware that there are requirements before you start a fit test that you need to properly do to make sure that you're sizing people properly and that they're well trained to go out into the field. All right, so let's talk about some components now. The first thing obviously is your machine, the QuantiFit system. If it's a brand new instrument like this one is, it will come with kind of a cover over your screen. I'll take that off and drop it down. So we have the QuantiFit system that comes out of a case. Every unit that we sell will come in a military grade storm case that's watertight. I'm not going to show you all of that today. You pull the unit out, and then the other components that we have, obviously standard power supply cable. This will come in the case as well. This plugs up to a wall outlet. I just so happen to have one here. And then what we'll do is plug this into the back of the instrument. And let me show you that really quickly because it's key. So the back of the instrument is going to have a power supply section. And there's more information on this in our Quick Start user guide, some other videos we have. But we have on the back of the instrument power connection. We have our on-off switch, which we'll use, and then our USB to PC connection, which we'll show you in a second, and then our calibration tube. So I'll connect up the back of the instrument, and I'll just push this in. Let me say one thing before I move forward. The power supply has an auto lock on the cable. You cannot pull that out like a vacuum cleaner from the wall or pull it, yank it. You really have to disengage that. That's something that we see issues with if people just yank it out of the back of the machine. We need to disengage that and pull the supply. So once that's in, the other components that you'll have would be your triple tube assembly, which we'll walk you through in just a second for fit testing. This is where we'll pull the air out of the respirator and challenge the mask with that breathing rate. The second component is going to be a start switch, or what we call a trigger button. Really, if you've ever done an audiometric test, it's very similar. Just a button that starts and engages the test, and that comes out of your case. Some people will keep the twist ties. I like to normally take them off and throw them away. But that plugs up right in the front. So in the front, very easy to find where the trigger goes. It just goes in the trigger selection, and then your triple tube connections there. Two other things that will come in your case, USB to PC cable, which we'll use during our fit test in just a second. And I'll set that there, we'll get to it. And then also a keyboard for standalone testing. So standalone testing, which we'll cover in more detail, will allow you to do testing on board of the unit. You can use your keyboard. You can also use this knob if you don't prefer to use the keyboard, but that is an accessory that comes with the instrument inside. So those are some basic components to the unit. I'll get into more adapters and connecting up to masks when we get to fit testing. So let's move into daily calibration. Once you have your unit connected up to power, you'll use your on-off button on the back. We should see the screen power up. And what it will do is it will immediately give us a recommendation to do a daily calibration. This is only on days of testing. So we get some really funny questions. People will say, do I have to calibrate this every day even when I'm not using it? Obviously not. This is only when you're doing testing today. Some people will even do this after lunch if they've gone and turned the unit off. You can do it as many times as you want to, but at least do it daily of testing so that you know the instrument's in calibration and in standards for all the tests you're about to conduct. So daily calibration, very simple. I'll just hit perform calibration with my knob there, and it says the sensor must be 0 before we start the test. So what I'll do is hit proceed. That zeroes out the tube. Just for this training video, there's a tube inside, obviously. It's our piston pump where we pull that consistent pressure against the respirator and measure leakage. So that's what we're zeroing out. We're zeroing out that pump. The next thing we'll do is connect our triple tubes. These tubes are very easy to connect up to the instrument. There's a few ways to know how to do it. The first way is 6 connections, 5 of which are female, 1 is male. So the only place on the instrument that this connection will connect is on the one female receiver here, and that is your flow tube. Then you have pressure across, and these are labeled as well. So the way that I like to do it is I just connect these up. Once I get my flow tube connected, I make sure that they're flat across. What key here is you don't want to see any crossing over of tubes. And when you're doing your testing, you just don't want to try to plug things where it looks like you're pulling them across each other. They're designed so they should be very flat and flush, and everything up front is tidy and looks good. So the next thing for calibration is your two clear tubes will connect to the back of your instrument where it says dual tube cal, okay? Now, one question we get a lot, and these can go either way, by the way, you can flip them around. They don't have a specific way they go, just connected there. There is an exhaust port that's there. Obviously, nothing goes on the exhaust port, but we will have questions every now and again about what connects to that. Nothing. That's for exhausting the air out of the back of the instrument. So that's your connection for daily cal. Now, what you'll see is what we call a closed loop. So this loop, when we hit start, will actually push different amounts of air pressure through. The sensor will measure this different amount of pressure to make sure that the pump is working. It'll make sure the sensor is properly measuring leak. There's a leak orifice at the front of the tube where we know we have a known calibrated amount of leak that we are aware of, and we should see that consistently at every pressure level. So while this is finishing, daily calibration is about 90 seconds without me talking the whole time. This is very different than a lot of other technologies. The setup time for this technology is extremely short. You plug up the instrument, you turn it on, you run it through a 90-second calibration, and you're ready to go. So there are no other requirements from environments, from alcohol solutions or anything else that would go in there, wicks. There's no requirements there. Once a calibration is successful, as it says here, we're ready to fit test. So it's very important that you understand that with controlled negative pressure technology, we remove the requirement for environment. We can now go do testing outside, inside, clean air, dirty air, wherever you want to do it. We also remove the requirement before a fit test for waiting for a 5-minute mask purge. Now you need to look at your guidances that you're using. Most every regulation requires for aerosol fit testing or even qualitative that you have to do a purge of the mask when you have the filter on, because if the person has donned the mask with aerosol inside of it with particles, or if they have particulate in their lungs, they have to breathe and work that out of the mask. With controlled negative pressure, we don't measure particles, we're measuring air leakage, so we remove those requirements. So again, once you've done your daily calibration, you're completely ready to do a fit test, and you'll be ready to go into testing there. So what I want to do now is walk into a fit test. We're going to do a standalone operation, a computer operation, and we'll walk through the full testing. All right, let's jump into fit testing. So there's two ways you can run our instrument. The first is standalone. This is the least commonly used manner of doing fit testing with our technology, but I'll briefly show you how to do that. So I mentioned earlier that one of the components you get is a keyboard. This has a USB connection. You'll run into the back of the instrument. You can input data, contacts, company information, whatever, into the unit. The system will store 500 fit tests on board. Those can be exported off to a USB thumb drive, straight into your software later if you'd like to do that. But keep in mind that it's a limited number of people. So when you get to 500, it begins to overwrite the original records that were on that. So that's why it's probably the least used method of doing fit testing. Still a great way to do it if you want to take it and do it standalone and you don't have access to a computer. So what we're going to cover today in our full training is walking through the way to run it through a PC through the FitTrack Gold software. So you can download the FitTrack Gold software through our website. It also comes with a USB drive on the side of your unit that you can download the software as well as training information and materials. All of that will be able to allow you to get jump started on your software. Once you load the software and launch it the first time, it will require you to add a company. So you'll want to go in and add a company. If you're doing fit testing on multiple companies, don't worry about that. Add the original company and you can always add more companies later. But if you're only doing fit testing for your department, your company, whatever, you can add in that company and then assign people in for fit testing. So we've done all that now, but before we jump into the software and fit testing, let me show you connections up to respirators, and then we'll jump into an actual fit test. So the QuantiFit can test all elastomeric mask up to CBRN level mask. We cannot test disposable respirators right now because when we pull a negative pressure, the air flows straight through the filter material. So anything that is half mask and up, you can fit test with this technology, with controlled negative pressure. So a couple of things. This obviously is a half mask elastomeric. The main thing you need to know about these respirators to test is that they have inhalation valves that must be propped open on the dual side that we connect up to. So let me show you that quickly. Inside of your unit will come a little bag of valve props. So we just prop open this valve and then we connect up our adapters. So the adapters are going to be a dual-sided adapter. I'll show you a single adapter in just a second. The dual-sided adapter will connect up just like a filter would. So you get the connection pieces up, you connect that side in, and then you connect your single port side. So for fit testing a half mask elastomeric respirator, you'll have a dual adapter. The dual tube connection, which we were talking about earlier, the two clear tubes would come to your dual tube side, and then your single blue tube connector would go to the single side. Again, if you have anything crossed over, that's a problem when you're doing fit testing. It should be very nice and clean every time you're doing fit testing there. So let me now show you a similar connection point, but in an industrial full face. So same type of requirement. We would pop in our valve prop, which is actually already in here, and then we would connect up our dual adapters to the full face APR or elastomeric full face respirator. So same thought process, same adapter, same connection. And if you're using a 3M brand half and full or MSA or whomever, a lot of times the filters have the same connection. So this one adapter can be used on your half mask as well as your full face respirator. We've got great information on our website with more technical documents if you want to look into individual respirators more here. So that's a half face and a full face, what we call APR mask or air purifying respirator. So if you're doing fit testing on, let's say, an SCBA, this is an MSA G1, what we have to do here is convert the respirator to take an adapter. So right now you have a regulator connection point for the mask. We have an MSA adapter piece. This can also be the same for Scott, Versions, Draeger, a lot of the different SCBA manufacturers. And what it does is it converts this mask to take what's called a DIN 40 or a NATO 40 millimeter connection adapter. So this adapter, as you'll see, is one piece. And what we'll do is we'll thread this adapter into the front of our adapter piece here. Same thing as you probably already guessed, the two clear tubes will go to the two ports and the blue tube would go to the single port there. So it just converts the mask to allow us to put our adapter to it there. The last thing you need to know is other masks, we have individual connections. So what we do is we bypass a converter, and like the new Scott Vision C5 mask, what we do is we'll actually connect it straight up to the front of the face piece. And let me turn it around. So you'll connect this up to the front of the mask and we'll twist lock it on like this. So this one connector will twist lock on. So there is no converter. So now our two clear tubes would come to the front and our one blue tube would go to the bottom. But either way, as you can see, it should be a nice clean look and everything there. So no crossover on the adapter ports. But again, great resources on our website to look at all different respirators because there's so many, we can't really cover those today, but hopefully that gives you an overview of the different types of masks that you might see when you're doing fit testing. So when you're ready to do a fit test, what we'll do is we'll jump into our software now and we'll have some screens pop up that will show you the graphs and everything there. But first what we'll do is we'll come in, the home screen on our computer is going to allow us to jump straight into testing. So if you don't want to get into adding personnel or getting into real details, if you're just doing fit testing today, you can simply come in, drop down our company or drop down our person. We'll select someone, we'll select our subject, we'll select our mask, and then we'll select our size, and we'll select our protocol. So today, what we're going to do is use our protocol through OSHA, and once we select that, we'll be able to hit test. So the nice thing about this home screen is you don't have to get into deep screens just to get started with testing, which is what most people need to do. Normally when you're working with the machine, you're needing to do fit testing. So this gives you the chance to jump straight into fit testing, find your personnel, add them in and do testing. Once we hit test, it will jump out a new screen for us here. And what you'll see is this will confirm all the different selections we've made, and it will also show us our breathing rate. So let me again mention here, the machine is going to challenge the mask when we do the read-on protocol, each different step. So we'll have the fit test subject take a breath and hold it. The machine will pull that heavy work rate that you'll see on your screen, and we'll actually measure the leak into the mask. So all of that information's here, and again, check your regulation and guidance to set this up properly, and we're happy to help with that as well. So what we'll do now is we'll hit start test. We should hear the tone on our instrument. That lets us know that it sees it, it recognizes through our USB connection, and we're ready to go. And that is one thing I guess I didn't mention. The USB port on the back, which we talked about earlier, just straight up connects to a computer through the USB. So now we're going to start our test. What I'll do is have Stephen come over, and you'll hear the tone that's making sure the instrument is connecting. Face forward step, which we talked about earlier on the read-on, but first let's connect up our tubes to the adapter. And just like we talked about earlier, you want the two clear tubes to be together, single blue tube to be separate, so there shouldn't be any crossover or cross between the tubes. Very clean, very easy. So now that we're ready to start, what we'll do is whenever Stephen's ready, he's going to face forward just like the instructions say. For the first step, he'll take a nice easy breath, hold it tight with his mouth closed, and then the machine is going to pull that breathing rate against the mask, which will show you some graphs on your screen. So Stephen, whenever you're ready, take a nice easy breath and hold it. And as the operator, I'll push the trigger button and hold this down. Now he can also do this as well, but for today's training, I'm going to hold the button as Stephen's going through. So what we'll see is a really good score on our first step. So that tells us a couple of things. One, great donning of the mask. It fits him structurally well. So now what we want to do is challenge the mask in different ways to make sure that it stays and the reseats on his face properly. So Stephen, you'll bend at the waist. Whenever you're ready, take a moderate breath and hold it. So we'll start the test there. So now we have Stephen bent at the floor. We're looking at gravity pull on the respirator. So how does the mask or respirator pull during a gravity step? So not much change, still a good number, a pass fit factor. So far the mask is really fitting Stephen well. So now what he'll do is shake his head vigorously, left to right, up and down. He's going to talk out loud a couple of seconds.
1, 2, 3,
Perfect.
4.
And then stop. Now what we're looking for there is, does the mask reseat? So when you're ready, you take a breath and hold it. Perfect. So what we're looking for again is, does the mask reseat? So after you shake your head up and down, talk, how does that mask reseat to the face? So we have a great score here. So now the unique part of our fit testing protocol are the last two steps. So Stephen, if you'll just loosen your bottom strap and top strap and take the mask off your face, and then what I want you to do is re-don it as you would in the field. So as the instructor, key here on training, I'm not allowed to really help him with this. What I should be doing is assessing to make sure that he can reproduce this good fit of the mask. Great job. When you're ready and you feel good with it, take a breath and hold it. And I'll press and hold my button. So he can take as much time as he'd like to re-don this. Normally, people that are well trained, a few seconds, take the mask off, re-don it, and you're good to go. So another good score. So Stephen, one more time, if you'll loosen your straps, take the mask off your face just like you would at the end of a day of a shift or whatever. Now re-don it like you're putting it back on in the morning. And again, I'm assessing this, making sure no straps get in the seal, making sure he knows how to properly don the mask. So here we'll let him get ready whenever he's ready again. Perfect, and we'll start our test. Now we're looking at how well, again, does the mask go back on and get a reproducible donning. Another pass. So Stephen's done a fantastic job. So overall, hold tight for me, Stephen. Overall, great fit test there. Obviously the mask fits well. Obviously Stephen's trained well. He knows how to get the mask on properly. Again, what we looked at earlier was we made sure when he came in, he did his fit testing exercise before all the requirements. Facial hair was checked, all of those things, but Stephen did a fantastic job. So that was a pass test. At the end, you can save it, you can print that, you can shoot it to a PDF. But let me show you a failed step really quickly, and we'll try to pull up the graph on your screen as well. So Stephen, on this step, we're going to go back and start a test again. If you'll just slide your finger in the side so that you create kind of a large hole. And now what we're going to do is whenever you're ready, take that same breath hold it, and then we're going to start. Now what you're seeing on your screen is before a good graph climbed and held pressure, and this graph is going to give us such a high leak that it couldn't even test further, meaning that it's just a constant leak in. So now remove your finger, which you did, perfect. I want to show them a good graph. So again, take a breath and hold it, and we'll start it. So you see how the pressure climbs, and then it pulls and it maintains that negative pressure at the breathing rate, looking for air leakage into the mask. So that's the accuracy of the technology. Very quickly you can tell. So step over this way for me, Steve. A couple of troubleshooting things here. You might think, well, why would someone ever put their finger in the seal? They wouldn't, or they shouldn't. But that simulates maybe a strap, that when you redon the mask, did the strap get stuck back in the seal? Did you redon it with facial hair that got stuck in that maybe wasn't there from the initial donning? So those are some things that we can now talk about from a troubleshooting standpoint. If you have failures, what you want to look for first are connections. So is it not really fit related? Do I have all of my connectors properly connected in and clipped in? Is my adapter solid? Are there any issues there? The other things you want to look for, which we just talked about, facial hair, also hair from bangs or sideburns, anything like that, straps, components from the mask or respirator. We've also found clothing can be an issue, so if they've got a tall jacket on or something like that, it can get into the seal. But then the last thing, and obviously most important, is actual fit. Do we have the right size? Does Steven know how to properly don and wear this respirator? All of the training components. And that's where fit testing really gets into an important part of your respiratory protection program. And we have a lot of good resources on troubleshooting, so we can't really cover all of those today, but we have great graph troubleshooting resources, great resources on different components that can get into failure to test. We'd love to help you out with those at our website, ohdglobal.com. If I can be of any further assistance, or us here at OHD, we'd love to do that. We hope today's training resource for RESP Fit has been phenomenal and one that can be useful for you as you get into testing and using controlled negative pressure. Thanks for joining me today.